So now we're going to go ahead and do an example 1 for linear regression. So a random sample of 11 statistics students produced the following data where X is the third exam and it's a score out of 80 and Y is the final exam. Can I predict the final exam score of a random student if you know the third exam score? Use a 0.5 level of significance. So we do this a lot in the real world. We will take something that we know and we will try to predict a future thing based on what we know. So as an instructor, if exam 3 is my hardest exam and I know that the final is going to have a lot of exam 3 on it, potentially I could predict how well those students are going to do on my final exam. So if I go to the next slide, I see the data, and here's the data I'm going to put into Minitab. And now I'm going to go to Minitab. So in Minitab, I already have my stuff in there. So what I'm going to do then is third exam, and then I have final exam. And remember, third exam is my X variable, and Y is final exam. So then I go to Stat, Regression, and Fitted Regression Model. So in the responses, I'm going to put final exam. In the continuous predictors, I'm going to put third exam. So again, responses are your Y variable, continuous predictors are your X variables. When we're dealing with huge sets of data, we could have more than one continuous predictor, but for this class, we're only going to have one. So I hit OK, and it gives me a lot of information. And I'm going to go back to the PowerPoint because I talk about all this information in the PowerPoint. So what I see, the first thing in my Minitab results is my regression equation. Y, which is the final exam score, equals negative 174 plus 4.83x, where x represents the third exam score. So all this information makes up my regression equation. The slope is 4.83. The y-intercept is negative 174. So my regression equation is y equals 4.83 times x minus 174. So I want to make sure I can make predictions using this equation. So I need to keep doing the following steps. But before I can see if it's significant, another thing I need to do is I need to go ahead and see what the R value is in the R squared. So what I'm going to look for first is I'm going to look for my R squared value. And here it is. It's 43.97. So that's my R squared value, and that means that 43.9% of the variation in the final exam scores can be explained by the variation in the third exam scores using the regression line. So basically 44% of the scores in the final exam can be attributed to the third exam scores. Okay, so there's a lot, that's not bad, 44%. So then there's other things that are affecting the final exam score. So I've got my R squared. Now I need to do my R value. And remember, my R value tells me the direction and the strength of the relationship or the correlation between these two variables. So when I take the 43.97, I convert it to a decimal, and then I take the square root of it. So say I put it in the calculator, and I'm going to do 4397, and then I'm going to square root it. So I get 0.66309. And when I do that, that gives me that 0.6631. I know it's positive because in my previous page, my slope was positive. If I go back here to my regression line, here you see my slope is a positive 4.83. So remember, your R value and your slope have to be the same sign. So I could say for that 0.6631, there's a positive moderate correlation between the third exam and the final exam scores. Okay, and I'm going to go ahead and throw that right there. Put it right here between the third exam, and final exam scores. Okay. That's how I would word those two, right? So I need to keep going now. I'm not done yet. So I really need to see if it's significant. So again, the first step that we do that is we do the hypothesis testing. And remember, for regression, your null is that there is not a significant correlation, and the alternative is that there is a significant correlation. All right. I'm looking at this p-value here where it says regression. This is the p-value you're always going to use. So the p-value is 0.026. And since the p-value is 0.026 and it's less than 0.05, we reject the null hypothesis. So that means this null right here is false and this one is true. So I can make predictions. So again, remember, this one means no significant correlation, and this one means there is a significant correlation. Okay, and that might make it easier. Okay, so remember, I found this one was false, or I rejected this one, oops, which means this one is the one I'm gonna use this one. Okay, so that's good, because then that tells me, all right, there is a relationship, so I can make predictions. So what does that mean? Well, I'm going to go back up to my equation line. So say I had a student, because I can make predictions, say I had a student who had a score of 75 on exam 3, on the third exam. So what would they make on the final? So I would do y equals 4.83 times 75 minus 174. Okay, so if I multiply 4.83 times 75, I get, all right, so we just keep solving this one, equals 362.25 minus 174. So y equals, oops, 1825. So on the exam, or excuse me, if they made a 75 on the third exam, I would predict him to make a 188.25 on the final exam. And remember, because I found this significant, I can do these predictions.